My name is Pierre Séguin. I started my career as a graphic artist and illustrator. Later, after moving to Kingston, I became a technical draftsman. I'm working in the mechanical engineering department of the Royal Military College of Canada, located in Kingston, Ontario. One of my jobs is to be the CAD instructor and support staff for the engineering graphic course. This represents 3 groups of Anglos and 1 group of Francos every week. A portion of this course covers the different type of projection: orthographic, isometric, and oblique, which is now less common because the CAD software cannot currently handle it. The drawing for practices, homeworks, and exam where the student will sketch the answer by hand in a grid require that the sheet given to the teaching assistant for marking has the matching answer for the question. The amount of work can become appreciable when we consider that we have 3 types of questions: ortho to iso, iso to ortho, and ortho to oblique, which is a challenge for CAD programs. To help myself and the other instructors, I wanted to automatize the process of creating questions and answers. I even explored some options where the template would produce a selection sheet of all the possible directions, as well as all the corresponding questions and answers. The software that we are using since 2004 is SolidWorks, and the fact that it is a parametric modeler where all the files are interconnected allowed me to build a part file for the model, another one for a series of grid panels forming a cube, which were combined in an assembly, and placed in a drawing file to show the orthographic views and the isometric all at the same scale. This sheet is to draw the missing ISO view, but the file also contains a sheet for the orthographic missing views, as well as the answer to both questions for the corrector. Another variation was to have the answer area at a larger scale than the question as shown here. For the oblique projection, the system was a bit different. Since it is based on the front view, I had a single large grid covering the part, which implied that I had 2 separate assemblies, one for the normal part bounded on all faces by the grid panels, and another for the oblique configuration placed behind a flat grid. This flat grid display was preferred by all the instructors, so the templates were updated to reflect the changes for the other types, which meant that now the isometric drawing would also require 2 assemblies because it would stop to be a regular isometric view as it was before. In this case, the normal part must be tilted at the proper angle in the assembly and placed behind a flat grid. But to ensure that the corners coincide with the grid intersections, a scaling factor must be applied to the configuration in the part file, and this will be the result. You are probably starting to wonder when I will come back to the subject of oblique projection. Now is the time. For all the assignments that we have in the course, we also have some plastic rapid prototype parts for the students that may have problems with the 3D perception. Here we can see the normal part photographed to mimic an isometric orientation, which is fairly close to my actual ISO drawing. I will go one step further, and in the same photo, I will show the normal and oblique orientation, but as the shadow can be annoying, I cleaned up the picture, then compared them to the drawing. Again, it is fairly close. The secret, which will be the subject of other videos covering the method, is to stretch the model in the right direction while keeping the front face of the object, including all the faces parallel to it, aligned with the front plane of the part. The original integrated system to automatically create question and answer based on the grid will be of interest mostly to drafting instructors or textbook publisher. By removing the grid for the answer, which now would have to be drawn by the students with the help of instruments, the construction method could be simplified, but the system would still be interesting to the same target users. Finding a way to simplify the system even more and make it applicable to a part already constructed could broaden the interest to encompass the general CAD users. It could become an alternative or a complement to the already existing isometric view. Even more interesting would be to apply it to multiple bodies at the same time and be able to set any angle or length for the receding lines. The basic principles will be covered in part 2.